Welcome to ICM online problem series in mathematics on abstract algebra. Problem number 3. Let x equals open interval 0, 1 and C of xr be the ring of continuous functions from x to r. For any x in open interval 0, 1, let I of x equals the set of all functions in CXR such that f of x equals 0. Then the options are I of x is a prime ideal, I of x is a maximal ideal, every maximal ideal of C of xr is equal to I of x for some x in x, and finally CXR is an integral domain. Let us discuss the answer. Option A is true. Let f comma g be two functions in CXR such that their product fg is in I of x. Then, by the definition of I of x, fg of x equals 0, which means f of x into g of x equals 0. F of x equal to 0 or g of x equal to 0 because R is a field. That is, f is a member of I of x or g is a member of I of x. Also note that I of x is not the full ring. Thus, I of x is a prime ideal. Now option B is true. Note that I of x is the kernel of the evaluation homomorphism at x, which is also an epimorphism. Then we get the isomorphism. CXR mod I of x is isomorphic to R, which is a field. So I of x is a maximal ideal. Now option C is false. First, let us have some motivation. Look at the graph of a continuous function defined on open interval 0, 1. Look at this region, that is open interval 1 by 2, 1. You can notice that the function is non-zero over open interval 1 by 2, 1. And the function vanishes at 1 by 3, 1 by 4 and so on. Also note that this function is not a member of I of x for any x which lies in this region, that is 1 by 2, 1. But the function belongs to I of 1 by 2 since that vanishes at 1 by 2. But we can modify the function by redefining the function in this region, that is 1 by 3, 1 by 2. You can replace this curved portion by a straight line like this and make the function not a member of I of 1 by 2. This we can do further. More precisely, consider I is equal to the set of all functions f in CXR such that f of 1 by m is equal to 0 for every m greater than n for some n in n. One can easily verify that I is a proper ideal. Define fm of x equals sin pi by x if x is less than or equal to 1 by m and x minus 1 by m if x is greater than 1 by m. This function is what you have seen already. Clearly, Fm is a member of I for each m. But note that for any x in open interval 0, 1, we can find a positive integer m such that Fm not in I of x. This implies that I is not a subset of I of x for any x in open interval 0, 1. This means that the maximal ideal containing I is not in the form of I of x. Now, the last option is false. Consider a continuous function defined on open interval 0, 1 given by this graph, this blue graph. Another function given by the red graph. It is easy to see that their product is 0, but none of the functions is identically 0. Therefore, it is not an integral domain.